The positive lead of the meter is going to get connected to the disconnected positive battery cable, the disconnected positive battery cable. We want to make sure that that cable is in a position where it's not going to come into contact with the battery. The negative lead of the meter, is going to get connected to a good vehicle ground. All right. Ideally, we want to have a direct connection to ground. We don't want to use the negative battery cable. We're going to do two separate meter checks that we're going to conduct, and we're going to do them in a particular order. First, we're going to conduct a voltage check, and then we're going to do a resistance check. Both meter checks have to pass before we supply a source of 12 volts to the entire vehicle. We're going to turn the meter to the voltage setting, and we're going to make sure that we're on DC volts. So we're going to take a look at the voltage here. Remember, half a volt is considered a pass. If you've just disconnected the battery, there's going to be some residual voltage, but you can see the longer we're connected to the system here, that voltage is starting to bleed off. So we do have less than half a volt at this point, and that would be considered a pass. If you turn your voltmeter on, and in this case you can see I've got about 300 millivolts. To convert millivolts to volts, we would need to divide by 1,000. You can see again that the longer we're connected, that voltage is starting to bleed off. So we would basically move the decimal point 3 places to the left, and this would be 0.25, 0.26 volts. Again, that's less than half a volt, so this would be considered a pass. The second meter check that we're going to do is the resistance meter check. We're doing this to check for an electrical short to ground. We want to make sure we don't have a direct short between the positive battery cable and the electrical ground or the chassis. So we want this resistance to be greater than 50 ohms. A resistance greater than 50 ohms is considered a pass. If the resistance was less than 50 ohms, that would indicate an electrical short and would be a failed test. So we still have the meter connected to the positive battery cable and ground, and now I'm simply just going to turn the meter over to the resistance setting to measure the resistance. We're going to take a look at the reading here. Again, if you've just disconnected the battery, there's still quite a bit of resistance in the system, and currently we are over load or over the capacity of this particular meter, which I believe is 40 megohms. So the longer that we leave this connected to the system, you're going to start to bleed off resistance, and eventually the meter should indicate a reading to us. However, this is still considered a pass. We have greater than 50 ohms of resistance. So you can see as we leave the meter on the system long enough, eventually the resistance drops below the max capacity of the meter, and we actually start to get a reading. In this case, we're at 16 megohms, 15. The longer we're connected to the system measuring resistance, that value is going to continue to drop, but it's never going to get less than 50 ohms. Typically on a system with no problems, the result of the resistance meter check will be considerably greater than 50 ohms. So again, this is a pass as far as the resistance meter check is concerned. So in this case, both of my meter checks passed at the battery. So now I can safely connect a booster pack or jumper cables to this vehicle and conduct crash data retrieval normally. I've got the positive of the booster pack connected to the positive battery cable and the negative of the booster pack connected to vehicle ground.